Hi all, I'm Pierre. I work at Near AI. Oh, finally. So today I'm going to speak about TEs and trying to fix your trust issues. So I do software with Near AI and yeah. So first of all, what are TEs? It's a very buzzy word right now. But basically, the idea is just like some hardware-based isolation that allows you to do like secure computation on some hardware. Basically, to give you like a higher level overview, it's just like, let's say you are OpenAI and you spent like hundreds of millions to train the new GPT model. But right now they have to use their own cluster and they have to own the hardware because they don't trust like GCP or AWS to own to host their model because yeah, like it's worth a lot of money. And so with TEs, basically it just allows you to cryptographically check that where you are sending your model, that there are proof that nobody is going to be able to actually access these weights, but you can still like use it as a customer. So we have a bunch of hardware providers now implementing TEs. So the most famous one is Intel TDX. It's a new version from SGX, which had a few issues that some of you might know, but TDX so far has been proven like super reliable. And what's super nice also, now we have GPU TEs, which basically allows you to run like GPU workloads in a full like TE manner. And it ensures like confidentiality, integrity, and attestation. So let's say now you are some user that you're interacting with some like TE workload. So you have an application running in inside an enclave. So we call an enclave a TE, whatever how you want to name it. And so as a user, you would want actually to check if you are discussing with the correct app. And so how to do this is that first of all, you have to get a quote out of the application. So it's like a process. You have few SDKs to do it. So when you get a quote, you get back a bunch of fields that basically will tell you, oh, this is the OS, this is the version of your like TDX, and this is like the hash of the software running inside the TE. And so then as a user, you get back this quote, and then you have to call what we call like an attestation service, which basically will tell you if the signature coming from this enclave, this TE is actually valid. And so this is the fourth step. It's coming back to the user. It's going to say, oh, yeah, this is genuine like Intel hardware. You can actually trust it. Just verify on your side that the hash of the app is the correct one that's running in there, because also it allows you to actually check that you are like discussing with the correct application. So usually for this, it has to be like a oh my god, it has to be like bills that can be replicated. And yeah, so once the hash is matched, you know that you are talking to the correct like app, and you can start like a TLS connection to this instance, and you know that nobody expects you and a confidential VM, so the T has access to your conversation. A few use cases that we've seen in the ecosystem. So one of them, like a very important one, is healthcare. So there are a bunch of people that tries to do like privacy preserving workflows. Let's say you do some very specific diagnostics, and so your users or you are sending some sensitive medical data, and of course you want like a like a proof that nobody is going to be able to access this data. For finance, let's say you train like a risk model on confidential data sets, and so you would want to know, like, to be sure that nobody has access to this data set, which is worth a lot of money. For AI agents also, let's say as a user, you're interacting with an AI agent that does like swaps for you. You would want actually to check that you are like a smart contract, that you are talking to the genuine AI agent and not like some scammy one. So you can do this with codes and attestations. And for AI, which I'm going to be speaking more about today, you want to protect inference and secure your AI model weights. So about like AI and confidential computing, like we know now these frontier AI models are worth a lot of money, like hundreds of millions of dollars. And a lot of like hackers are trying to actually get these models out of the owners to get money out of it. They try to leak to get all the data out of the models that, or like the interactions from the user to these providers. And also they try to temper the execution by basically swapping or putting like a proxy in the middle and basically forwards all your requests to OpenAI. But with TEs, actually, you can check that you are talking directly to OpenAI and not to some scammy provider. So to do this, like you have to do a bunch of different processes. So first of all, we have to provide like private inference to users. So as a user, you would want to know that, as I said already, that you are talking to the model that you are expecting to be talking and not somebody else. You want to verify that you are talking to like the correct model. And so as an enterprise, like a lot of companies now are blocking access to employees because they can't really trust like these like third-party providers that basically are not going to leak all the data. So if actually you are able to check that you are talking to the correct model and it's not like trained on some copyrighted information, then you can use it. And a community-owned model, so this is for mostly like researchers. They would like they would pull a bunch of data points, and together they would like put some money together and train an AI model. So to do this, we introduced the DCMA paper. Feel free to look on internet. This is like a link, so if you get your hands on the presentation, but you can check the paper. So our implementation to this is what we call the private ML SDK. So you can check it on GitHub. It allows you to do like model training and fine tuning directly inside TEs. It predates what I'm going to be speaking of next about Anthropic new paper, and it's really easy to integrate and to use into your ML workflows that are currently running. So with Fala Network, some of you might know them. We have been working on this ML SDK. And basically now we are leveraging CPU attestation, so CPU TEs and GPU TEs. And thanks to this, you can do some model training. So it's a very similar process. It's just that from the CPU now, you actually also get the attestation from the GPU. So the CPU is checking that it's a genuine GPU. And once once it's doing the attestation and it can trust it, then it's going to load the model in there. And as a user, you do the same. So when you are discussing with the CPU TE, you would get both attestations, both quotes, and you would like attest them to make sure that you are talking to a genuine system. So there is this paper that came out like nine months ago from RANDS, which is like a nonprofit organization. They work very closely with policymakers, and basically the paper was all about the importance of securing AI models. They found like 38 attack vectors, and they categorized like in 5 different categories the kind of like hackers that can that are a threat to these systems. So from from somebody in his room trying to hack into like your company to like a statewide crime organization, and also they have like implemented some framework for security levels from like a non-secure application to like very, very secure. And so Anthropic has been working based on this paper to now release like 2 weeks ago this paper about confidential inference. And basically what they're saying is that now they want to do everything from TEs, because then they would match the SL4 and 5 requirements from the RANDS paper that I mentioned before. So there are still some threats. You still have to rely a little bit on the hardware, because like let's say there is a flow into Intel TDX, like hackers could still like take advantage out of it, and there is like some risks also of misconfiguration. Let's say your engineer messed up something at the setup of this instance, there is still a risk. But once this is set up, like the whole goal for Anthropic, for example, one of the use cases is said that now like not one or like nobody has real access to the prod environment, and so you have to have like 5 or 6 engineers actually approving something before like it goes through the pipeline and it gets deployed inside these TEs. So really like the vision for confidential AI. So on our side, we are working on decentralized and monetizable infrastructure. So let's say you train a model, then you want to monetize it on a per usage basis. So together with the community, you train some model that's very good at like, for example, I don't know, therapy. Then you could say like it's $1 per inference. We are also working based on the RANDS structure, the security model, and Anthropic also now is working a lot on like risks and how to mitigate them. And so there is a clear need for a secure, decentralized, monetizable, and confidential AI. Just some insights on our implementation. So this is comparing like a model running inside TE versus non-TE. So we wanted to know the overhead. So it's quite low. It's from 1.5% to 12%. Basically, the 12% is for smaller models. Usually, when the smaller the model, the more time you spend like encrypting and decrypting the inputs, which is what's very costly. But if it's like very big models, like a 32B Quen, you can see it's 1.5% because the time is mostly spent computing inside the GPU and not on IOs. For 70B, like it's a bit skewed because it's 12%. It's just that it's way too big. So this was running on one H100 GPU, which is yeah, it's not enough to run this model. So of course the model like was performing very badly. Yeah, so TEs are essential, not optional. That's what we see from the industry now across like AI and blockchain industries. And so it's really like a collaboration that we all need to work together. And feel free to reach out to me afterwards if you're interested in working with us. And yeah, I'm open to any questions. We have plenty of time if you guys have any like TE questions. And yeah, thank you. Any questions? Anybody interested about TEs? Yeah. Do we run the nodes? Yeah, so we have a few bare metal nodes. It's like a cluster of, we have 12 machines of 8 H100s, but we are trying to actually go forward and provide like a decentralized compute layer for everyone. So if you have like a machine of 8 H100 GPUs, then you can join this network and you might get some training workloads coming to you. Any other questions? No? Okay. Thank you, guys.